Okay. Hello, everyone, and welcome to our first Aviva Process Simulation training session. My name is Bruna Giron. I am an Academic Success Manager for the Americas region at Aviva, and the primary objective of these training sessions is to prepare you with essential knowledge about using our simulator. So we have designed this curriculum to cover all the topics for successfully attempting the challenge posed by the upcoming academic competition. Furthermore, this is also a wonderful opportunity for you to clarify any questions you might have. So the session is being recorded and the recorded material will be accessible to all the registered participants of the competitions. I will ask you to keep the microphones muted during all the sessions, and at the end, we will reserve a time for answering all the questions. So during the training, if you have any questions, please write the questions in the chat, and we will answer at the end. Before I start, I would like to introduce Richard Pelletier. Uh, he is a valuable member of our team, and he started his journey at Aviva straight out of the school. He is a chemical engineering, graduated from Rowan University with an impressive 17-year working at Aviva. He holds now the position of a principal customer support engineering, and he will provide the sessions and share his knowledge with us. Richard resides at Delaware, US, with his wife and his three wonderful boys. Richard, I hand this to you. Thank you for joining us.
Thank you, Bruna. All right, I'm going to share my screen and then we'll get started. Okay, thank you all for attending. As Bruna said, I'll be doing the training over the next 5 days. The sessions that we're going to be having throughout the week are going to go pretty quick. There's going to be a lot of topics that we're going to try to cover. I'm going to summarize them in a minute when I get to that slide with the agenda. But I'm going to go pretty fast paced to get through everything and make sure that everything you need to know about how to use the software is covered. If you run into any questions that you have or you feel you need more explanation on something, I went too quick over a certain topic, just type them into the chat, and at the end I'll do my best to answer all the questions. If we can't answer them all during the session time itself, then I'll be happy to answer these questions outside of the session through email and answer any concerns that you guys may have. Outside of that, Bruna, if you could keep handling the, people coming in, I'd appreciate it. That way I don't have to come back. And then I won't make the slides full screen because I'm going to be bouncing back and forth between slides and the software, spending most of my time in the software once I start getting into it. But for now, we're going to start a little bit with the slide materials. And the slide materials that I do have here, if you guys are interested and want a copy, we should be able to provide those as well. So I'll work with Bruna after the class is over to see what we can do about getting you guys a copy of these slides. Okay, so this is going to be an introduction to Aviva Process Simulation. The course is going to mainly focus on teaching you the aspects of the software that make Aviva Process Simulation unique within a simulation world of different products that are out there. There are two major aspects to the software that we're going to cover in a lot of detail, which is the fact that it's a multi-mode simulator. So it has different modes of operation that you can run in to simulate similar behaviors of other software. And then we also have an approach which we call our model library approach, where we use different model libraries that help us to simulate different types of processes. And so a bulk of the class will be focused on those two different areas and explaining what's so significant about them and the concerns related with all of them, and how they all work together to make Aviva process simulation tick. But outside of that, there's obviously quite a bit more that we're going to want to cover, so that way you guys understand how to use the software. So today's session is mostly going to be basics. It's going to be an overview of the software, the user interface, how to navigate around, starting a new simulation, how simulation management works, because we do a little bit of a different sort of file management in this software than most other software programs. We're going to talk about some basic concepts like roles and units of measure, building out your flow sheet, subflow sheeting options. We're going to do some discussion on different ways that you can do data entry and topics related to data entry. And then as we get towards the end, we'll talk about different workflow recommendations that we recommend when you're building a simulation, ways to recover from mistakes if you have problems, the concept of snapshots, and that will sort of go hand in hand with recovering from mistakes, but snapshots are also used for many other capabilities. So we'll talk about those. And then a couple of basic outputting capabilities that we'll discuss. There's going to be other things that are going to touch on some of these topics later on in the further sessions, but this is meant to get you just sort of started to begin with. And then as we progress through the week, we will get into more and more detailed information on specific concepts. So session 2 is predominantly going to be all about component and thermodata and the different modes of operation. Session 3 is going to be a lot about model library management as well as individual model concepts. And you can see I've highlighted a few here that are going to be of importance to you for the academic competition that we're going to cover. Session 4, we're going to pick up a little bit more with some individual model concepts with the economics model library, but then we're going to get into the Excel add-in, which is an integration between APS and Excel. That allows you to do custom reporting as well as interfacing between the two softwares. And then there's a handful of advanced capabilities that you might find useful, especially for the academic competition. So we're going to cover those as well. And then Friday, when we have session 5, we're going to talk about reactors, reactions, columns, and the concept of model writing in more detail. This is an optional session if you would like to attend for this year's competition. But we suspect that in the future, there may be reasons where you're going to want to use these capabilities. And so we are having an optional 5th session to cover them, mainly because these recordings are going to serve as the basis for future competitions as well. So we do have that optional 5th session that might not be required for this year's competition, but you're welcome to attend for that as well. Okay, so let's get started. What is Aviva process simulation? The easiest way to think about this software is sort of like what a smartphone does, right? Back in the day, before you had a smartphone, you would have many different devices that were used for very specific purposes. So you might have a camera. That's the only thing it did was take pictures. You might have an MP3 player that all it did was play music. You might have a GPS, and all that did was help you navigate, right? And each of these different point solutions were good at what they did, but you had to have a different device with you, and so you're carrying constant, many different devices, and they're always with you. It's that way you had access to them, and they also don't integrate very well with one another. And then along came the smartphone. And the smartphone was a new device that combined all this together. And at first, maybe it didn't do everything quite as well as the individual products, but the convenience factor of the smartphone, having everything all together in one place on one device, made it such that you were almost always inclined to use that over the other point solutions. And as the years progressed, the smartphone quickly started to outpace the individual solutions in terms of functionality and how well it performed a lot of the same functionality. And so now we have a Viva process simulation. If you think about it the same way, before Viva process simulation, you had many different types of process simulation programs that were out there, many of which that we have here at Aviva, such as Pro2 and Visual Flare, DynSim, and so forth. And these programs, they're all designed to do very specific things, right? So Pro2 is commonly known as a steady state heat and material balance type of process simulation program, which you typically use to do design types of calculations for whatever it is that you're trying to simulate, right? And so a lot of times in this type of program, you don't have to worry about certain levels of detail that you would have to worry about in other programs. So you make assumptions and makes your modeling a lot easier. It's just a different approach than, say, doing a dynamic simulation where you have to factor in controls and dynamic related behavior into the calculations. And so you'd have these different programs that were for different uses. And, you know, they did the job for that. But many times in the engineering world, you do one type of analysis, and then you need to take that and move on to a different type of analysis for the next stage of your, you know, overall project. And the programs often don't communicate well with one another or translate from one to another very well. And so you duplicate work that increases the risk of data entry issues and other problems. And it also requires more time because now you have to, you know, redo a lot of what you already did in one software and another software. So now we have a Viva process simulation, and with that mode approach and model library approach that I just talked about on one of the prior slides, we can now take what all these other programs were doing in different individual products and combine it all on a single platform. And so with a Viva process simulation, you have one program and it can do everything from steady state heat and material balance calculations for design work, steady state pressure driven calculations for rating, and dynamic simulation where time is a factor in the calculations. And we can switch between those different modes on the fly. And we can model different types of systems, such as what you're going to be doing in this academic program with competition with the renewables library is something that most process simulation programs don't have the capabilities of simulating. They don't have the ability to simulate a wind farm or a solar farm, have a hydrogen electrolyzer model that converts that electrical energy into generation of hydrogen, right? And so, you know, this is a program that, because of the way it's designed, allows us to be able to do that and handle that across many different ways of studying that type of process. Okay. So that's a little bit of background on what a Viva process simulation is. I'm going to jump into the software now and start talking about the user interface and just navigating within the software so that you're familiar with it. Okay, so this is what a Viva process simulation looks like when you first open it up. What you're going to see here is that up on the top, there are a bunch of different ribbons for different purposes. Each one of these ribbons is fine-tuned to show you a very minimal amount of information for a very specific purpose. So one of the key things about a Viva process simulation is that we try to streamline the software. Now, we don't show you extraneous things that you don't need on a regular basis. We try to make it so that everything that you are constantly going to need is visible, and everything else is either put into a model or hidden from view, which we can expose. And I'll talk about how to do that a different way, right? But the idea is it's all about making it clean and easy to understand what it is that you're looking at. So this first ribbon here is all going to be about things that you typically need to get started with your new simulation. And so you have everything from the simulation template, which is an option that allows you to pick specifically a certain model library to start from whenever you create a new simulation. All this does is cut out this step here, which you're seeing in the middle of the screen. All right, I've already tried to create a new simulation by clicking this little plus sign, right, or by going to File, New, and it pops up with this where I have to pick one of these 5 model libraries. And when I pick one of the model libraries, that's going to create the new file. This option up here under the Start menu is just skipping this step. If I make a selection here, then when I create the new file, File New, or click this plus sign, it's automatically going to create the new file in the model library that I have selected here. So just skips this startup screen. Okay. This next part here is for roles. We're going to come back to this, but roles are a way of streamlining the interface, making it so you see more or less information. It also opens up your accessibility to different areas within the software. All right, so we'll come back to this and talk about this a little bit more in a bit. The next part here is for units of measure. The selection here is to choose from a specific slate of units and measures. A slate is nothing more than a collection of different, chosen units and measure for different properties, right? And so you can create your own slate by clicking on this button, coming into here, going create slate, and then once you create it, you can open it, and you can see all the different properties. I'll move this down so the background's not bothering you. You can see all the different properties. You find the properties of interest, and then you change the unit of measure selected to whatever unit of measure you want to utilize. Right. So if I have, this in pounds an hour right now, but instead I really want this to be, tons per day, I can just change this. And so everywhere in my simulation that uses this slate, it's going to have mass flow rates reported as tons per day. Okay, so this is how you go about creating the slates. The main thing is that once you create your slate, you have to pick it from this pull down to use it. All right, so just make sure that you are picking it in your simulation file from this pull down. Otherwise, you're not actually going to be using your units measure. You'll be using what's called internal units of measure, which are very similar to SI units. There's a couple properties that differ, but generally speaking, it's very similar to SI if you use the internal units of measure. The next couple options up here are for the look and feel of the software. So right now we're looking at a theme called the light theme. I believe when you first install the software and you're looking at it for the first time, you're probably seeing this theme, which is our blue theme. So if you want to change it, you're welcome to change it. There's also a green theme, and there's also a dark theme, which is very good if you're used to using, say, AutoCAD, right? It's very similar to that. Light is my personal preferred one, the one I'll be using throughout the training. And then the canvas background, which just to show you what this refers to, this area here, when you create a new simulation, this big white space right here is my canvas. This is the part where I'm going to build out my simulation file. I can change that background color from here by picking a different color, as you see. All right, but we're going to stick with the default, which is from whatever theme we chose, which in this case is the light theme. So it's going to be white. And then all of your printing related options are going to be here. It's unlikely you're going to need to print anything for this competition since everything is being handled digitally. But if you do want to print something out, you can do all of that through here. You'll notice the print option is not under the file tab, right? Like a traditional print option is. We're going to come back to the file tab after I go through the rest of the user interface navigation. But the file tab is strictly for file management. It's where you go to create new files, open files, and so forth. All right, so we're going to come back to that, talk about that in more detail in just a minute. right? But this is on the start menu if you want to do anything related to printing. Now you'll notice when I started talking about the start ribbon, I skipped these first two areas. And the reason why I skipped them is that these are a little bit more in-depth conversations that we're going to have at a later point in the presentation. The first one is all about the different modes. This is how you switch from one mode to another. So how do you switch from process mode to fluid flow mode to dynamics, right? That's these different buttons here. We're going to talk about the different modes in more detail tomorrow. And then the second area here is for different badges that we're going to utilize that are going to help us understand what's going on in the file and if we're building the file in a smart and correct manner, right? And so we are going to be looking at these badges, and we're going to want to have access to be able to see these badges and be able to change modes whenever we want. So what you'll end up finding is that these two sections appear on pretty much every tab. Right? As you see, I switch between the tabs. These two sections stay as the first two sections, right? Because they play a very significant role in your everyday usage of the software. Okay, so you want to make sure that you're always paying attention to these, especially the badges up here, and we'll talk about those later as far as what they mean and their significance. The next three tabs that you see are all for the different modes of operation. Each mode has certain things that are available to it in terms of features or capabilities within the software. These features that you see here, if you see it mentioned on multiple of these tabs, right? So let's just take one, snapshots. If I see snapshots here and here and here, right, it's the same interface with the same information, no matter which tab you access it from, right? So snapshot data, under this snapshot manager, for example, is the same whether I access it from this ribbon, or this ribbon. It's all the same information. All right, it's the same way with everything else that is common across these ribbons. Now, you'll notice many of these sections are some of those advanced capabilities we're going to talk about on Thursday as part of session 4. So case studies, scenarios, optimization. Down here, we have some other information as well that's different. We will talk about anything that's mode specific or an advanced feature at a later point in one of the future sessions. All right, so for now, just understand that these tabs are for mode specific capabilities, but things that are common across these different tabs are the same information no matter which tab you're accessing it from. That's the most important takeaway from this right now. The Edit View tab is for customization options. I'm going to throw a couple of models down on the canvas here so that way we can see some things in action. So just give me a second. All right, so if I wanted to change the way that this looks or the font size or style, anything along those lines, same thing with this line or this valve, what we could do is we can select the object, and then we have an option here which changes what the fill of the object is, right? So maybe I want to make it green, right? And then I can also change the line style as well. So maybe I want to make this blue. I don't know if it's difficult to see that. Maybe I'll change the green to something a little bit easier to see the difference. There you go. Right, so we can change the way that this looks and feels through this option here. The font that's down here for the label, we can change what it is that it uses. We can also change the size. We can make it bold, italicized, underlined, change the color. Right, so we have different options that are available to us in terms of changing the way models or streams on the canvas look and feel. When it comes to building out your simulation, there are some options here that are going to help you with your building process. So The option here for rulers adds this little ruler here to the canvas so you can see where the different coordinates are. You can also add grid lines so you can see where all the grid is. And then as you're placing models on the canvas, there are two options here that can help. Guidelines help to align your units so that it makes it easier for you to keep them in the, the same orientation and exact line as one another of prior models on the canvas. So you see these three lines that are going up and down between this flash drum and the valve. It's just helping me keep these aligned. Those are guidelines. And then there's also snap to grid. So if we do snap to grid, what that's going to do is it's going to help. You see how the movement's a little bit chunkier now. It's not as fine-tuned between them because now it's trying to keep it on this grid in the background. Right, so it's just trying to help it stay more aligned as well. These are options that are turned off by default, so if you want to turn them on, you will have to turn them on through this area. I would recommend you do that before you start building because they're typically used to help you build your simulation out. The next area is to show and hide different parts of the software. So let's say I closed out of the model library manager and I needed to get that back. I can come over here, I can click the checkbox for model library, and that'll turn that back on. All right, same thing with other areas of the software. There's a bunch of different areas that we can turn on and off within the software. Okay, this part here is for data entry. There are two different options that are available here. One of them is to turn on colored borders, which just helps you identify where key pieces of information are within the model's data entry windows. It is typically required data entry. Green is something that's at a default. You're welcome to change the default. You don't have to change the default. I'm just trying to highlight that it's at its default. And then anything that's colored in blue indicates a user change. So I changed this value, hence the field is blue instead of red. You'll notice when I changed this value, not only did this box change color, but I had a badge here that was this badge, and it's now this badge. So one of the things about the software is that we actually utilize badging for most of our indicators as opposed to colored borders, which is why this is turned off. So if you like the look and feel of what other software tends to do with colored borders, you can turn this on. But within our software, we typically use these badges to help us get a feel for what we need to enter and the different aspects of the software. We're going to come back to the badges when we get down to some data entry discussions. So we'll come back to this. This part here just turns on and off this specific badge in the solution status area. You'll notice if I turn it off, you'll notice it grays out and there's none of that red badge anymore within the models. It's not that it's not there, it's just hidden so we don't see it. There's a reason for this, and we're going to come back to that later when we talk about these three badges. The next part here is for moving labels. If I tried to move this label, you'll notice that it moves the whole model. So if I want to move the label, I have to unlock the position, then I can move the label. Then if I lock it again, you'll notice it moves the whole thing and keeps the ratio. I can also turn these labels on and off. So if I want to turn it off for the models, I can uncheck this. If I want to turn it off for the streams, I can uncheck this. You'll notice terminology in the software we call unit operations models. We call what you would typically call a stream a connection. There is a reason for that. We may get to that on session 5 when we talk about model writing. But this is the terminology that's used within the software. Streams are typically referred to as connections, and unit operations are typically referred to as models. Then we have some zooming and panning and other capabilities related to those over here on the canvas section. These options are also available over here on the menu. And there's also some similar capabilities down here in the overview section. So if you want to zoom in and out, you can use these, or you can use your scroll wheel with the control to zoom in and out. You can go up and down with your scroll wheel, or you can pan if you click this, and you can move around that way. It's another option. Using this overview section down here, this blue box, if you click in between the set and like in the middle of the blue box, you can pan it around. You can resize it from here. You can also zoom in and out right from here as well. One of the reasons why you might want to use this overview section is that the overview always shows you the entire simulation. And so you're always going to see, even if it's just really, really small, all of the models in the entire simulation all at once here, which does make it easier to navigate by moving this box around and zooming in and out by just resizing this box. If you try to navigate just using the flow sheet, you have to do a lot of scrolling and moving and panning manually, which can just be a little bit more work. One of the other things about navigation when it comes to zooming, panning, and moving around on the canvas is if you hit Control F on the keyboard, it'll bring up a find capability, which will allow you to search anything on the canvas that matches the series of characters that you type in. So I'm going to throw down what's called a variable reference. This is a way of seeing different variables on the canvas without actually having to open the data entry windows. I can also use these while they're on the canvas. So I put down a variable reference here for the mass flow rate. I can also put a molar flow rate down here like this, right? And now I can see these values straight on the canvas. I can change these values right on the canvas. I can also switch specs if I wanted to and change these values like this, right? And so this gives me a lot of flexibility as far as how I work with the file using variable references. Now, the whole reason I put these variable references down is that when I'm searching, depending on what it is that I'm searching for, if I type SRC1, right, the first hit I get is the source, but I will also get variable references on the canvas, right? And so this find functionality is useful because it'll find everything that's on the canvas that matches the string of characters you type in, right? And then finally, when you're happy with any configuration options you've done, you can always save them through here. If your install somehow gets messed up and you want to get back to what you had before, you can restore from the saved layout. And you can also do a factory reset, which just resets it back to the default. Right. Okay, so that's most of the customization stuff, and that's under the Edit View tab. The next tab here is for integration with another software of ours called Aviva Engineering. You will not need to use that during this competition, and so we will not be covering that during this course. But if, say, in the future, you're working for a company, you have Aviva Process Simulation, and you have Aviva Engineering, you want to integrate the two, that would all be done through this tab. Okay, so that's what you're seeing on this tab. Then there's an advanced tab, which has what I would call features that don't fall nicely in one of these other ribbons, right? And so in here, we're going to see things like a reaction generation tool. This is an Excel-based tool that you can launch that will help you generate a reaction submodel. On Friday, when we talk about reactors and reactions, we'll show this in use and how this all works. But unless you're using reactors, you won't need to use this. The next part here is for accessing our program that manages all of our component and thermo data. It's called our Thermo Data Bank Manager, right? TDM for short. And so this launches that software. It's always running in the background when you're using our software, but it's not something that you have access to unless you click, say this button to launch it and then see and use it. And what's nice about this is that not only do you get to see our property information, you can use TDM to create your own custom components, custom properties for existing components, custom thermal properties, all that can be managed and stored in here and then accessed in any simulation file that you have. We are not going to be talking about TDM in this course, as it's not something that you will have to use for the competition, but this is something that companies may occasionally use for proprietary data. And they'll store their proprietary component and thermo data in here so that their files can use them. And that can also be protected so that users can't just see the proprietary data when they're using the simulation files. The next part here is for creating a column output report. We don't anticipate you using any columns within this academic competition, but we will have training on columns on Friday in that optional session. And if you end up ever using the software for columns, this is an easy way of exporting column results to an external Excel output report. And then this last option here is for migrating from other software such as Pro 2 into Aviva Process Simulation. Currently, the migration capabilities are limited. We're not going to go in detail about what that means and what's available. Just know that if you have a Pro 2 file, you can get sort of a jump start in using that Pro 2 file in APS by using this feature. This is something that's going to further expand in the future to support other programs and more capabilities even within Pro 2. So this is something that will eventually get built out more and more as versions go on. Right, so as you can see, most of these don't, again, fall nicely under one of these other ribbons, but they are here if you want to ever use any of those types of capabilities, you'd have them under here. From everything that I've shown so far from these menu options, if you think about it in terms of this year's competition, you're mainly just going to use these first 5 tabs that I'm showing: Start, Process, Fluid Flow, Dynamics, and Edit View. This one here you won't touch at all, and this one might get used in the future, but not for this year. All right, and then the last part is all about help. You can come over here, go to the help section. You have to excuse my machine. I have a very high resolution machine. There's a little bit of a defect in this version where the search bar is non-existent at such a high resolution. So normally when you come in here, there's a search field up in about this spot here. And you can search this to browse through all the different help documents that you see that are broken down off to the side over here. But for now, the way I can show this, we have different sections in this help documentation that will help you better understand how to use the software from all the different ways that we use it to build simulations and navigate the software, get output, writing custom models. So this is, again, the topic we'll be talking about on Friday. Excel reporting through the Excel add-in. This is what we'll be talking about on Thursday. Model-specific documentation, this is a little misleading, this section, because it doesn't actually talk about the models themselves. I'll tell you how to get that help in a minute. It talks about the libraries, each one of the different model libraries. So what are those model libraries and what models you'll find in those? If you want model-specific help, let's say, for example, you're in the process model library and you want to know more about the drum model that's in here, you want to use the right-click help that's in this area to get more information specific to that model in that model library. Now, it's very important that you access the help from the model in the specific model library that you're using. You may be using different model libraries, and you may find that certain models, such as a valve or a pipe, are common from one model library to another. They are not always the same model. The pipe, for example, in the flare library is different than the pipe in the cooling water library, which is different from the pipe in the process model library and the steam model library, right? So this help documentation is specific to the model in the model library that you accessed it from. And that's very important to understand. right? That way you get the exact help that you need for that type of model. Coming back to here, this is for our real-time optimization offering. You will not be needing that during this class. This is for thermodynamic information, which does break it down by different methods and different types. So there's a lot of information that you can find in here on different thermodynamic methods. This will tell you about different example files that are available to you. So if you come up to here, file import, which is effectively the same thing as an open, right? So file open, there is a folder that's pinned to your quick access area. Whenever you install Aviva Process Simulation, the folder is called SimCentral Examples. SimCentral is the old name of Aviva Process Simulation. So whenever you see Aviva Process Simulation or you see the word SimCentral, they mean one and the same. So SimCentral Examples in this folder has a simulations folder, which shows you a bunch of different simulations that you can import and open up within the software, and that'll give you an idea of how different systems are built and the things that went into building those different processes. We have a bunch of examples here in this first folder that are what we call documented, meaning there's a document here that tells you all the different little concerns and things that went into building every one of the SimX files. And the SimX is the extension for APS files, right? So every little thing that went into building these SimX files is documented in this guide here, right? And so all of these are documented examples. However, there's an undocumented examples folder, which has even more SimX files that you can reference for learning how to build other applications. You'll notice in particular, we draw your attention to this one here. This is a renewables example. So is this, these two here, SS2, SS3. These are renewables examples, and a big part of your competition this year is doing work with the renewables library. So these two SimX files may be something of interest to you to see how we go about using that library properly. And we're going to, of course, have training on those libraries, but this is a sample that you can refer to get more information and see how certain things are done. Okay, and then there are some video tutorials that are cover a little bit of the stuff that we're going to be talking about throughout the course. There's a bunch of different topics here, and that's pretty much it when it comes to the help. All right, so at this point, we've covered pretty much most of the ribbons. Just to tell you what some of these other areas are that you're seeing on the screen real quick. This section over on the left is referred to as the Model Library Manager. This is where you go to access the different model libraries. Every single tab that you see here is a different model library, right? And a model library is nothing more than a collection of models for a specific purpose, whatever the process is that the model library is for, right? And so when you look at this one here, which says process, this goes, with this selection here when we created our new simulation. This process model library has all of the different unit operations, some sample fluids, which are component and thermo definitions, some sample performance curves for things like pumps and compressors and so forth, and then different submodels that are used by these different unit operations. And they're all designed with the intent of supporting what the purpose of the process model library is, which is typically for refining and chemical processes, right? So if you notice from this description here, the process model library says simulate chemical processes, right? Perform heat and material balances, size pipes, valves, and other equipment while in process mode. Check two-phase piping systems and fluid flow mode, do controls analysis in dynamics modes, right? So that's kind of the purpose of this model library, and the models that you'll find in this model library help to support that. Now, the process model library is the most versatile model library that we have within the software. It does pretty much everything you would want from the chemicals or refining type of background, those industries, right? And so you're going to find models in here such as the column or different types of distillation columns, reactors. So we come down here, we have a conversion reactor, an equilibrium reactor, a Gibbs reactor, different types of reactors for different reactions. We have different types of heat exchangers that are in this model library. Okay. If I show you the renewables model library, what you're going to find is that it's going to have models that are specific and support what the purpose is of a renewables application, right? So in here, we don't see distillation columns or reactors or anything like that because renewables systems don't use those. They use wind farms, solar farms, batteries for storing energy, electrolyzer for converting energy to hydrogen, right? And so there's a bunch of different objects that are in here that support what the purpose is of the renewables library, right? And so every model library has a different purpose. All of the models that exist in a given model library serve the purpose of the model library, right? And so when you're going through these different tabs, you're looking at collections of models, right? Even if the models are fluids or performance curves, like these down here, all right, or submodels that aren't actually equipment, but sets of calculations for specific purposes that the equipment models are going to be using. These are all models, right, terminology-wise. Right, so every one of these tabs is a collection of models that supports whatever the tab is for. Right? Controls, this tab here. This is all controls models that are used to support dynamics. Right? So if you are starting to do dynamics, you're going to want to come in here to add in PID controllers to be able to control different aspects of your models and have those PID controllers manipulate something else, such as valve positions, right, in order to control the behavior. Right? And there's other types of controls models that you'll find within here as well. But they all support what you typically do in dynamics. So it gives you a little bit of a breakdown of how these different models and model libraries work. We're going to get into more detail on this entire section as we progress through the training. So for now, I'm going to leave it where with just that bit of information. Right. The next part over here is what we refer to as the simulation manager. You may not need to use this. So if you want, you feel free to close out of this area. I'll quickly explain what it is though, so that you know what you're looking at. The simulation manager shows you everything that you have in your simulation itself. Right. So when I look at this, I have a source, I have a valve, then I have this connection here that connects the two. Right, so the source is here, the valve is here, here's that connection. And I can expand these and I can keep going down the tree structure to see different properties of interest within these models. For some reason, it's, there we go. I'll come back to roles in a second. But so I can expand these to see different properties of interest in basically a list view. Right, it's an easy way of navigating to specific information without having to go looking for that information on the canvas in the models themselves. Right, but most of the time, most users prefer to just look at the models, and so the way we sort of teach this is through the best ways of using the canvas to find information that we're looking for. So everyone can please mute their line.
Déjalo encima de la mesa, Cari.
If everyone, thank you. Appreciate it. Okay. You may also see some other areas I have certain things already closed, like one that may be open as a keyword view. This works hand in hand with the simulation manager to provide even more information on specific selections within the simulation manager. Again, you can close these if you don't want them open. All right. So at this point, that's most of the overview in regards to the interface and sort of some of the navigation options. We're going to come back to a little bit on all of this as we progress through different topics. But the next thing that I want to get into is creating a new file and the file repository, this menu option here that says file, what this is and how it works, right? Because it's going to be important. It's a little bit different than the way that most other software works. Right, so when you create a new file, right, initially you'll probably have to pick one of these templates to start your new file, right? Even if you do file new or you click on this plus sign, unless you have a selection here in the start menu simulation template, right, you're probably gonna have to pick something. And when you create that new file using one of these, the first thing you're gonna find is that it's going to rename the file sim and then a number. All right, sim is the default naming convention, and the number is always going to be the next number that's available in the repository. Now, what is the repository? Up here under the file menu, you can see a list of all of the simulations that you have opened in your install of the Viva Process Simulation. This is referred to as the file repository. This is not a most recently opened list, right? You go into other software, you come into the file menu, and sometimes you see like 5 or 10 different files that are listed as most recently opened and are quick access for you to be able to reopen them. That's not how this works. These are all of the files that were opened on your machine, and they're stored in a very specific directory for the Viva Process Simulation installation. That directory is what we refer to as the simulation repository, and it's from that location where you are actually working with and editing your simulation file. Right, and so this will become a little bit more clear as we go through and explain this. All right, so when I look at this right now, I have a sim2 file that's in my repository. The easiest way to access that repository, if you need to get here, is when you come to your Windows Explorer, you go to that Sim Central Examples folder that I told you is under Quick Access, and you backtrack 2 folders. Right, so 1, 2. Once you're here, you're at the main area where most of the APS files are installed. All right, files meaning the installation files, not your simulation files. There's a folder here called Sims. This folder is the simulation repository. So if you notice, there's a bunch of SimX files here. They're every single file that I have opened on my machine. And you can notice right here, I have Sim2. Right? So this is the file that I'm working with right here. Now, if I make a change to Sim2, that change could be adding a new unit operation. It could be changing a value. It could be swapping a spec, changing a value. It could be something as simple as just moving this model from there to there, right? Everything that I do in the software is automatically saved. That's one of the nice features about APS is that the program's always saving. And so you never lose work. If for some reason your computer shuts down, let's say your laptop runs out of battery and all of a sudden APS shuts down unexpectedly, most other programs, that would be potentially catastrophic because you didn't get to save your file and now you've lost all this work. In this software, you simply come back to the software, find the file, and reopen it. When you reopen it, you're back to where you were, right? Because it's always saving. Every little change you do to the file is always saving. The thing that you need to understand, though, is that it's saving the file in the repository. the file that's located here. All right. Now, one of the things that you can do, and you should be doing with your simulation files, is you can export these. Think about the export as a save as. Right. So let's say, for example, I want to save this file and have a backup copy that I can come back to just in case. Right. No, that way, if something happens, I can come back to it. I have it stored and saved. So what I would want to do is I want to export this to a SimX file somewhere. So I can go File, select my file, go Export, and I can choose a location where I want to export this to, such as my desktop, right? And let's call this Test, right? Or Demo. Demo might be more fitting given what we're doing. Now I'm going to call this Demo. So I saved a copy of my file called demo.simx on my desktop. Now, I'm going to continue working with my file right here, right? So maybe I add another unit operation, right? And I make some changes. I come back. Maybe I'll swap these back around. Let's add some variable references on the canvas, right? So I make some changes. Everything I did there is a different point that it was saving, okay? Let's say for some reason this file is at a point where, maybe I don't want to keep using this. I want to go back to where I saved, right? So what I want to do is I want to go File, Import. And when I import, I can browse and find a SimX file, such as the one that I exported on my desktop, this demo file. Right? So if I import this, you'll notice that it only has the source. It doesn't have these variable references, doesn't have the valve, doesn't have this, it doesn't even have this change, right? If I come back over here, you can see still uses the old conditions, right? And that's because when I was working with Sim2, after I exported to this demo SimX file, it was saving everything into the repository, the file located here. And so that file that I exported to my desktop is a static copy. It never changes. Nothing about that file ever changes once I've exported it and created that copy. Okay, so it's important to understand this for a couple different reasons. One, you're going to want to be able to access your files, especially when you have deliverables for this project. You're going to need to export SimX files to be able to send them out, right? You can either go to the simulation repository and get the version of the file that's most up to date based off of what's in your simulation repository, or you can export to a SimX file, right? And put it in a location that's easy for you to navigate to, or a particular spot you want to find, right? And that's another way of finding the file, right? And then you can send that file via email or something, right? But when you're working with other people, for example, let's say I send them that demo file, right? Now they're going to import it on their machine. They're going to have the demo file, and they're going to be working with it, and they're going to be making changes to it, right? Okay, let's say those are the changes they made, right? Once they import it into their machine, it adds it to the repository. But it's not that it's adding, it's more like copying it, right? It's now a copy of the original file in the repository. So when I go to my repository here, here's my demo file. And the changes that I just made here are saved to that demo file. Let's go back and re-import that demo file on the canvas. It doesn't have the pipe or the connection, right? Because that file is a static file. So even if I file import, which is like a file open, it creates a copy of the file in my repository, and then I'm working from the copy. It is not editing and saving the source file that I imported, right? So you need to understand this behavior in order to be able to work with your files properly and to share them either with us as deliverables or with one another as you're working on your project. Okay. All right. Another thing to note about that, when I imported it, since it already had a file in the repository called demo from the first time I imported, it renamed the file using the default naming convention, sim, and then the next number available, which is now 3, right? So that's why this file is called sim3. Right. Okay, so we're going to come back here. We're going to start to talk about how to build the flow sheet, some of the ways that you go about building out the flow sheet now. Before I do that, I want to talk about this option that we went through quickly before called roles, right? So roles are a way of changing what you see, the level of detail and the options that are available to you in many different areas within the software. Right, so let's take this source and we'll open it up and expand it. Right now, when I'm in the source, I can see all this different information right here in Simulation Building Role. Simulation Building Role is designed to be a streamlined view, which shows you the most commonly used equipment, models, variables, and parameters within a given model on your canvas. It's designed to give you the most common things, but not everything. It's supposed to be streamlined, and so you don't see everything that is actually there within the software. That way it doesn't overwhelm you. If you come over here to the model library area, and I click on this process model library, you can see, just looking at the number of objects here, how many things appear in this list. Just take note, there's no scroll bar here, right? Because it ends right at this point here, right? Sorry. In Simulation Building Role, it's showing me these things because this is the stuff that's most important for most users to be able to use the models and the capabilities for the process model library. If I switch to model writing role, however, you'll notice now there's a scroll bar and I can scroll down and there's a lot more models here, mostly submodels. Okay, but there's a lot more models here. There's also a lot more information in this window that wasn't there before. It actually didn't update. Let me close this and reopen. 1 second. There we go. All right, so there's even more information here that wasn't there before, such as these properties down here, these couple properties right here, right? Some of the options that are up here, right? Because model writing is going to expose everything. It's going to make it so that I can see everything that's available to me within every asset of the software. So a lot of times when you're working with the software, what you might find is I can't find a certain property, right? Or I can't find a certain model. What, where can I find that? It might be based on the role you're in. You might just need to switch from simulation building to model writing to expose it so that way you can see it. Right, now, there are other instances of why you might not be able to see something. We'll talk about those in different topics, right? But typically, if you can't find something, it could be that it's being limited on you in terms of the role that you're in. The other thing about the roles is that it also gives you added capabilities that you didn't have before. One of the things you can't do when you're in simulation building role is create or import a model library. But when you're in model writing role, you have that capability of creating or importing a custom model library, right? Another thing that you'll find is that one of the nice benefits of the software is that everything in the program is pretty much open, and you can see all of the different equations and variables and the way that models are written, and you can understand how they work, right? So if I ever had a question like, how does this drum calculate a certain property? I can right click and I can go to edit, and I can come in here and I can see here are all the different equations that the drum model is using, right? And I can see all the different variables that it uses, right? And I can go through this section, this area, which we call the model editor window, And I can get a better understanding of the behavior of the model simply by navigating this window, right? But what I can't do while I'm in simulation building role is make changes. Everything here is grayed out. If I wanted to make changes, I could switch to model writing role. My program is acting up. Give me 1 second. I'm going to just restart the software. Okay. So in model writing role, I have the ability to change anything I want, right? Including these equations you see in these models, right? It's kind of the point of what model writing role is for, is to be able to create custom models. And that opens up the ability for you to be able to make changes across any model, including our models, unfortunately. So you do have to be careful about that. There are certain placeholders in effect that can help you with any sort of problems that might arise from you editing things, but I would just recommend you don't. So I'll leave it at that for now. But the model writing role gives you that added flexibility, that added capability of being able to write your own models and make changes to things that you wouldn't normally be able to do with simulation building. Right? So there's many different advantages to these two different roles that you're going to find within the software. All right, so you'll notice I deleted the prior files from my simulation repository. I work in support. If I had every single file I ever opened maintained in this list, it would be a mile long. And so I tend to only keep files that I use for demoing or for training exercises. That's why you see the list that you see here. So I started a new one because we're going to start building out a sample simulation so you can see some of the different steps in building out a simulation. And we're going to start from scratch to do that. And so I created a new file. We're going to stay in simulation building role. We're going to switch to US refining units of measure, which is basically English units of measure. All right. And then we're going to start building out a very simple simulation here. Right? And as we go through building this out, we're going to talk about a couple different things and sort of go into detail about certain topics that are important. All right, so first thing first, we're going to add a source. Every simulation needs to start with a source. And so we start, and when we come into here and we look at our source, we can see there's a bunch of information in here that we're going to want to check and verify and make sure the conditions are correct. And so we have up here, there's a predefined fluid under this fluid type. This fluid is air. So if we look at the composition here, right, it's nothing more than air in the fluid. Right. The default fluid in the process model library is air because it helps to make modeling any process as you're building it out easier. All these models are designed to initialize very easily with that as a subset. And so that's why you see this selected. But typically, you're going to want to switch that. And you're going to want to use a fluid that's more specific to the process that you're trying to simulate. In this case, I'm going to go and browse for a specific fluid. In this case, I'm going to do this C2 to C8 fluid, which is nothing more than a couple hydrocarbon components. Right, so we got ethane, butane, hexane, and octane. In your process, you're probably going to need to create your own fluid. And that's what we're going to be starting with tomorrow in session 2. So session 2 tomorrow, we're going to talk about how you create a fluid, which is going to be component selection, it's going to be thermodynamic selection, and all the concerns that are related to both. All right, but for now, we're just going to choose a predefined fluid. All right, and then we want to go through and we want to check these conditions, make sure everything's correct. So I might want to come and change the overall flow rate. And so I can make this 8,000. I want to change the pressure, right? And so I can make this 150. I change the pressure, temperature. I'll make this 225. If you notice, I'm just sort of rounding the numbers that are already there, nothing crazy. I'm also going to change the compositions here. I'm just going to make it an equal molar of every component. All right, and so I've gone through and I've entered my information. And so when the first thing that you're going to notice is that data entry is as simple as that. You can either double click on the model or right click, go to mini properties. It opens up this window called the mini property inspector, and you go through and you can enter the different properties that you want to enter. If there's a property you have that is currently not specified by the simulation, you can specify it and free something else up to balance it out and specify that instead. So the source here defaults to having the mass flow rate specified, the temperature and pressure specified, and a composition. But maybe I want molar flow rate specified instead of mass. So I can swap these specs, and then I could change this value if I wanted to use the molar flow rate as my data entry. And now we're going to come back to this swapping the specs and some of the things that are going on with the badges in this in just a second. But I want to skip forward and just show building out a file real quick before we come back to that. So I have a source that's satisfied now. And now I want to add my next model and start building this out. Now, one of the things I want you to take away from this is that notice I did this one model at a time. I started with a source, I entered its conditions, and now that this is satisfied and everything is green up here on the solution status, now I'm going to add the next model. And so I might add a drum, add this down on the canvas. I'm going to connect these two models. Okay. And one of the things I want to always try to make sure that I'm doing is that these badges remain green before I add new models to the simulation. And so they're green right now. I want to check the drum. I want to make sure the conditions in the drum are as I want them to be. All right, and I can expand these areas that are not expanded and change things up if I need to, but everything in here is good with how it's currently defined. So I'm going to leave it as is. Right, and so everything's green, and I might want to add my next models. So I'll come over here, I'll get a sync. While you're in process mode, you don't have to have syncs. You could theoretically just have a hanging stream that doesn't go to anything. You could also just not have a stream at all. Technically, all of the product information is stored in here already within the drum. And so you don't even have to have the stream itself. However, it's traditional in most software to have some kind of product stream. And in this software, typically, if you have a product stream, it ends on a sync. All right, and that's because when you go to fluid flow or dynamics, syncs are required in order for those modes to operate properly. So you want to make sure you add in a sync in order to connect the product, and so that it's not left hanging and you're prepared for those other modes. Right. Now, the sync itself doesn't have anything that's specified. It's all calculated properties right now. So we don't have to do anything with that. So what? Another sync for the liquid product. All right. Now we're satisfied and everything looks good. Right. Now, there's a couple things that you can do during your building process that might be beneficial to you. One of the things might be you might want to rotate for some reason. Right, if the orientation is not correct. So you can do that by grabbing this and moving it around. You might want to resize models, right, if they don't look right to you. You can also, if you resize it and you don't like the size anymore, you can reset the size. Right, so that's another option. I showed you some of those customization options up here for changing font styles and colors and so forth. So you have those options available as well, right? And now, if I'm going to continue building, one of the things that I could do is, let's say I know I want to add in a valve in between the source and the drum and the sink, right? So if I want to add in valves on these streams, in most software, you would have to do something like this. Add it on, disconnect, reconnect, add the new product, and now you're good to go, right? However, with Aviva Process Simulation, you don't have to disconnect manually. If you're dragging and dropping from the Model Library Manager onto the canvas, you can insert onto connections. So I can hover this over to here, and it says insert onto this line. If I let go, it automatically inserts it and connects and adds the new connection. All right, so this is for any model. As you're building, if you want, you can insert like this. All right, notice it does not work if you try to do this after it's on the canvas, right? It won't insert, right? It has to be done as part of adding it from the Model Library Manager. Let's say I also want to create another section of my process that has, the same models, for example. And so instead of having to drag and drop everything, I can simply copy this and paste it to add in similar models onto the canvas for use for another part, right? So this is good if you're trying to build out a lot of the same types of processes in succession, one after another, or if you have different areas of the software that you want to be able to reuse parts again in terms of the way that you have it set up and defined. Copy and paste is great. This also extends across simulations. So I've copied, I paste, right? So it can go across your simulations as well. Right, so if you have information in one file and you want to add it to another file, you can do so through our copy paste capabilities. Another thing that's useful is that if you do your copy with variable references and you copy them at the same time, then when it pastes the variable reference, it will automatically update it to point to the new model, right? So this is pointing to this. If I had just copied the variable reference and pasted the variable reference, it's still going to reference the original model, right? So copying both of them at the same time, the program's smart enough to automatically update that information. Let's say I wanted to create a subflow sheet where this portion of my simulation resided on the subflow sheet. One of the things that I could do is I can add what's called a flag model. Now, this is not required for subflow sheeting, but this is recommended. And this works in the process model library because the flag model is a process model library model, right? But I can insert a flag model here. And now when I highlight, there's a little bit of feedback. So if everyone can mute, that would be appreciated. When I highlight these and I move them to a subflow sheet, this will give me an indicator that this product is moving to another flow sheet, and that on the other flow sheet, we'll see the same flag model serve as the source, right? So to do a subflow sheet, the first thing you want to do is go to Tools, drag and drop the flow sheet icon onto the canvas. And you'll notice if I double click on this, it opens up another canvas that I can look at, but it's blank, so there's nothing here. But it did open up these different tabs along the side here where I can navigate between the main flow sheet and the subflow sheet. So now I can highlight these models. I can move to the subflow sheet. And when I go into the subflow sheet, I can see here's my flag model. which serves as the starting point for this, and same flag model here. All right, so this allows me to see or move different sections of my simulation and sort of compartmentalize the canvas. It allows me to declutter everything that's on my main view by putting it into separate sections. There are other advantages to this as well. This flag model specifically can be put into what's called an isolate mode. When it's in isolate mode, everything going up to the flag stops its flow right here, and then everything proceeding after the flag pretends like the flag is a source, right? So you can see conditions are specified here. And so I can use this to my advantage in isolate mode, because now each section, this section here and this section here, are technically two different networks, and I can use one or the other at my leisure to evaluate different things. Let's say I'm trying to do different side set of calculations, and I want to understand what those are without affecting the main process. Or let's say I'm trying to troubleshoot something. This could be a model that is not converging, and I want to know why it's not converging. I can isolate this and troubleshoot why this is not converging by having just this little section isolated. So there's a lot of different use cases for having this flag model in isolate mode and trying to work with your file in that regard. Okay. We are going to take all this back and bring this simulation back to, you'll notice I'm undoing. It's something we haven't talked about yet. Using Control-Z on the keyboard, but there's undo up here, and on the different mode tabs, there's also an undo button. But this is the first process simulation program that allows you to undo. And we highly recommend that you use the undo for various reasons. One of which, as you see here, I'm bringing myself back to where I was before, which is where I want to go from building out the rest of the simulation. All right, so I'm going to not undo the subflow sheet, so I'm going to have to manually delete that. All right, but I wanted to get back to here for building out the rest of this demo. All right, but the undo allowed me to do that rather quickly and rather easily, whereas if I were to have to do that manually, I'd have to delete everything, move stuff back to the main flow sheet, and every little thing that I did was a point where I could have introduced a problem into the file, right? And so the undo, what's nice about the undo is that it immediately goes back to where you last were. And this is particularly useful for troubleshooting convergence-related issues or other problems that you may run into with the way that the simulations solve it. If you undo back to where you were last good, where you were last square and solved, then that gives you a point that you can move forward from and try to, figure out why you're struggling to get past, that point to whatever it is you're trying to accomplish. So undo is a very, very useful tool that you can use within the software. And you'll see me undo quite a bit from time to time. If you ever see something revert back to a state that I was in before and you didn't see me click anything, it was probably me doing Control-Z on the keyboard to undo. All right, so now I have the simulation. Next thing I want to do is maybe take it to fluid flow mode and dynamics. And so one of the things I might want to do is put a level control here. And so I'll put a level control of the level fraction on the controller. Now I'll control this valve so that way it adjusts the flow of the liquid product to control the level in the drum. I'm going to change this to be a level fraction controller, and we'll leave it on direct. And I could tune this if I wanted to. I could change tuning parameters for the controller. That way it changes how the controller behaves and how quickly it responds to changes when I'm in dynamics. For now, I'm just going to leave these at their default. And now I can switch to fluid flow. In fluid flow, this is a steady state mode of operation, but it's pressure driven. So if I look at my source and my sink, you'll see that pressure conditions are specified at my boundaries, meaning our endpoints. All right, and based on these pressure conditions and fixed sizes and other conditions such as controller set points, it's going to dictate what the flow distribution is throughout the network. And so I could use this to see how flow changes through this drum, right? Like if I make the sink pressure here higher, let's say I make it 150, okay, then all of the flow is going to push down and go out of, or sorry, made it higher here. So let me see, it went back, it adjusted this, yeah. So made it higher here, pushed all the flow out through the through the vapor product to try to maintain this 50% because it couldn't keep a consistent volume. So it's actually a little bit off of what I was trying to show because of the level control. But these changing conditions are going to dictate the flow through the network. And so instead of flow being specified and then split at a certain ratio based off of the normal duty calculations that are occurring within the drum, I have a little bit more of an impact happening from the hydraulics aspects of the simulation here and the pressure losses through these valves and so forth. Okay, so we're going to revert back, go back to where we were. I can go to dynamics now, and if I wanted to, I can run my dynamics. Notice when I run initially, what's going on? It's running, nothing's changing. And the reason for that is because the simulation's at a steady state solution. It came from fluid flow mode, which served as sort of an initialization point for dynamics. They're both pressure-driven modes of operation, so they share a lot of the same conditions. And now when I'm running it, unless I make a change, it just stays at that steady state solution. And so I need to make a change to start seeing dynamic behavior, seeing how other process conditions change in order to meet the new steady state at the conditions that I've specified. So I specified a 75% bubble fraction. So in order for this to hit 75%, it needs to start lower, or let's say closing the valve so that less of the liquid product is going out here and starts to build up within the drum. So we can start to see that. You see the OP output is going down. The PV has yet to respond accordingly, which has to do with my tuning here, but eventually this will start to go, or actually it is responding, it's going up to match the set point, yeah. So this will keep going down until this PV matches the set point value, 0.75. Okay, so for sake of time, we're not going to run this out anymore. There's still quite a bit that we want to cover before we're going to end it for today. But this gives you a brief demo of how to go about building out a simulation and a little bit of use in all the different modes. I now want to take this back to process mode and start to talk about some of the other things that are of importance here. All right, so first thing I want to talk about is that these badges up here, these are very, very important, and they're on every tab because of how important they are. The first badge is what's called the input badge. This is to let you know areas of different models that you either need to confirm or change specific values for. Right? This is something that is built into every model, so that way you can check and make sure that particular pieces of information are correct. Right? You're going to find a lot of times when you add a model, like we added these valves, they're going to come with certain default conditions already specified. And those default conditions are just our starting points that we put into the software so that the simulation is solved when you first place the model on the canvas. All right, but that doesn't necessarily mean they're going to be your process conditions. So you need to go through and check these and change them as needed. In this case with these valves, all three of them are telling me I should check and change the pressure drop that's specified here if it's not correct. And so I can change the value and hit enter, and that clears that badge. I can confirm the value that's already there just by putting it in and clicking enter. That also clears the badge. You'll notice these badges are disappearing over the valves as well as I do this. The other way that I could clear it is by shift clicking on the badge itself next to the variable. And that will also confirm whatever is already there. And once all of the variables or parameters within the simulation for every single model have been cleared of this badge, then the overall badge up here will turn green. Now, this is not required for your simulation to solve and run properly. However, it's recommended, especially as novice users of the software, that you follow these badges from the top, meaning if this is red, follow it down here to the individual models that show the red badge, such as these, go into their data entry windows and check their values wherever they're highlighted. All right. This is going to help make sure you didn't miss anything important within the file. All right. So not required, but highly recommended that you watch and confirm all these badges. The next badge here is what's called the spec badge. Right? We refer to this commonly as being square or being not square, right? And so when you want to swap specs, let's say I want to swap my molar flow rate for my mass flow rate. When I spec this, or when I unspec this, right, the simulation becomes unsquare. All right, you notice the badge turns red up here. When I hover over the badge, it tells me how off I am. The whole purpose of this badge is to maintain an equal number of known and unknown conditions within the system so that it can solve all of the equations within the software. This is an equation-oriented software. It's trying to solve all of the equations provided by the different models at once. And it knows the relationship from one set of equations to another set of equations simply based on what variables exist in those equations. And so when I, in this case, unspecified the molar flow rate, it's telling me I need to add another specification. And it knows the things that are related to the molar flow rate that I can specify instead to help balance this out. And so when I follow this down and I look at the canvas and I see all these different red badges, right, because there's a bunch of red X's, all of these different areas are likely to have a candidate to resquare the simulation. And those candidates are these red boxes that you see. These are the specification boxes. Then you either check them or uncheck them to resquare the simulation. So in this case, it's telling me I can add that spec back in, even though I removed it. I can add it back in. That'll resquare the simulation. I could specify the mass flow rate instead. That'll resquare the simulation. Or I could also specify something in a different model. So I can swap specs across models because of the relationships that the program knows between the different equations. So it knows that even though I had a molar flow rate specified here, if I instead specified, let's say, XV2's mass flow rate, this one here, I can set a value here that helps back calculate a source flow rate here. All right, because they're related between the different equations, and it knows how to calculate and relate those back to one another. So the program is smart enough to tell you the candidates that it's asking you to either add or remove. All right. Now, in this case, it asked me to add. If I'm overspecified, it will ask me to remove. So I can see that here. Now, notice when I did it this way, it's giving me different options. So it's really going to depend on what it is that you've either clicked to specify or unclicked to calculate that's going to change what options become available because of where you were coming from and what it understands as the relationships here, right? But in this case, because I have two mass flow rates or two flow rates being specified, it's identifying things that are related to flow rates for the source in particular that I can use to re-square the simulation. And while it shows me things like pressure and temperature, those properties don't really make sense, right? If I unspecify pressure, yes, it creates a square simulation and a solved one, but that's only at this exact set of values, because if I change this to a different value, there's no way it can calculate it properly, because this does not convert equally to the value that's specified here in the mass flow rate, right? So I have created a situation where I am specifying two different flow rates when in reality, if you think about it from a real system, you can only have one flow rate being specified at a time, right? So it's usually advisable that when you do this, when you are swapping specs around, you swap specs between things that go together, that play off of one another well, and that makes sense from an engineering perspective, right? If I specify this, it only makes sense to unspecify this. If I specify this, there's many options that are here, right? So I could say I have a vapor fraction and a temperature specified, so in which case maybe I need to calculate the pressure. I have a vapor fraction and a pressure specified, in which case I'm calculating a temperature, right? Those make sense from an engineering perspective, right? And I need to use my judgment here on what makes the most sense for my system based off of what it is I'm trying to control, what it is I'm trying to calculate, right? So you want to swap your specs around accordingly. The other thing about swapping specs that's important, and this is a very highly recommended workflow recommendation, is that you always resolve swapping your specs first and then changing your values. So I specify this, I want to unspecify something else and then change the value here before, I move on, right? I don't want to do this. I don't want to specify, and while this is on square, change the value of the thing that I specified and then resquare the simulation. That can cause you a lot of problems for a lot of reasons. For sake of time in this training, we're not going to explain those right now. Just trust me when I say, don't do that. Always resolve swapping specs first, then changing values. And that's a lot easier when everything's in the same window. It's harder when you do something like this, right? You specify this and you unspecify this. These are across different models. And so you might not have this window already open, and you might be here and you think to yourself, oh, I already spec'd it. I have the window open. Let me just change the value. No, don't do that. That's a bad idea. All right. Always resolve swapping your specs first and then change your values. Right. Okay. So we have about 22 minutes left. I want to get through some of the other topics here and still have time for questions and answers. So we're going to move just a little bit faster here and talk about some different things. I do want to resolve this. I didn't finish talking about this last badge. The last badge is whether or not you're solved or not. So if you create if you have a state where you don't have a solution, and I'm going to create that here. All right, so my simulation is unsolved right now. I'm square, all right, which is usually the first step. You have to be square before it can even attempt to solve. All right, so always make sure you're square. That's the only way of it even being able to try to solve. All right, but if you're square and it's not solved, you'll see red X's over different models where there are failures in the calculations. And so in this case, You can ignore these. These are input badges. They're exclamation marks inside a red circle. You want the red X's. That's this model that's failing to solve. And you can come into the model and you can see maybe what it is that's failing to solve. It'll be highlighted with some red. And if you hover over the message, a lot of times it'll tell you what the problems are, right? So you might see messages like this that tell you what some of the issues are. So in this case, it's telling me xv6.dp1. And sorry, I can't use my cursor to move it over there, or else the pop-up will go away, right? It says that equation has a residual of 49.68. So that's the equation that is trying to solve that has the highest error margin. And so the equation's written underneath, which is our pressure drop calculation. And so we can see there's an outlet pressure, P2, an inlet pressure, P1, and a pressure drop, DP, in that equation. And when we look down a little bit further, we see the different variables that make up that equation and what they're currently calculated to be. And then at the bottom, it tells us there are certain variables that are on their bounds, right? P2 is on a bound. Right, so when you look at P2 and you look at this, it says variables unsolved because it's on its lower bound of 1. Right, can't go any lower than where it's currently at. Now, 1 is using internal units to measure, which is not PSI. So that's why it's saying that. All right, so what this effectively means, if you interpret the message, is that it can't solve the pressure drop calculations for this valve. And when you start to dig into that and understand why, you can clearly see, well, I have an inlet pressure of 0.19 psia with a pressure drop of 7.25 psi. So clearly, if you try to apply this pressure drop to this inlet pressure, it's going to fail because you're going to run out of pressure. It's too much pressure drop, right? And so this message is telling me a little bit about that. These messages on these red X's are not always going to be this clear, though. A lot of times it's going to have this level of information, but it's going to be on a problem that's much harder for you to understand from a mathematical perspective. And so a lot of times you might want to also check for warning messages. These little yellow badges are warning messages. Anytime you see a warning message, it's hard-coded for the model because of something that is likely to happen within that model under a certain condition that was triggered, right? In this case, we know that whenever the pressure drop is greater than the inlet pressure, that it's not going to solve. And so we can check for that in this model. And if it happens to happen, right, pressure drop is larger than the inlet pressure, we can flag this specific message. And so when we developed the valve model, we wrote this message, and it tells you as the user, pressure drop is larger than inlet pressure. You should decrease the inlet pressure or increase the inlet pressure, right? Decrease the pressure drop or increase the inlet pressure, right? One of those two ways will fix the problem. And so a lot of times when you see warning messages, it's a good idea to hover over those warning messages to get more information that'll help you better understand how to fix the problem that you're seeing. All right. In this case, I could fix it a number of different ways. I can set this pressure drop to be lower than this. So I can do maybe 0.1. It's still not going to work. So let's just go 0.01. All right. So that's one fix. All right. Another way that I could fix this is I can increase the source pressure. So now that resolves it as well. All right, so this badge is going to let you know if you failed to solve, and you can follow it down to red X's on models on the canvas to get a better idea of what's going on. Now, I want to go back to undo, and I want to also talk about a couple ways you can recover from mistakes. Let's say you get a situation like this where you're unsolved, and you can't figure out what's happening. You want to try to understand what's going on. First thing you want to do is undo back to when you were last square and solved. Okay. So I undo. That gets rid of the addition of the valve. And so now I want to look at it and I want to understand what is it about adding this valve that's making it fail, right? That's going to help me troubleshoot my convergence. All right, but the undo allows me to get back to the state where I was last good. And that's something you're going to want to be able to fall back on very commonly as you're building out when you run into problems. Other ways that you can recover from problems are exporting to a SIMX file, right? So if you export to a SIMX file, you have a static copy of the file, right, that you can always come back to. You can always re-import this file to get back to where you were, right? And so naturally, you're going to want to export when you have a square and solved solution so that when you import, you're back at being square and solved, and you can continue working from that state. Other options that are available to you are right-clicking on this menu option here under the file name. And you'll notice there's a bunch of different things that are available here. You can rename your simulation, right? I can also do that by double-clicking here or accessing the file and renaming here. So there's options there. I can export my simulation from here. So this right-click on the file name up above the canvas gives me a bunch of different options other than the thing I'm about to talk to you about. And there's more we're going to talk about at another time, right? But I can choose this option here to discard changes. And what this does is it will close the simulation and get rid of anything that you've done from the moment you opened the file. This is good as a last-ditch effort. You can think about this like closing your file without saving. Remember, this program is always saving, right? So every change you make is always saved. And so if you get your file to a state that's no good and you can't get back to being good for one reason or another, then this may be your only option to get back to where you were last good, which hopefully was when you first opened the file. Right, so that's what this option means here. All right, and then one of the other ways that you can recover from making mistakes is if you have snapshots. So snapshots are a way of saving the state of the simulation such that you can come back to it at any time. Typically, we use this as a means of doing case studies, right? I have a certain set of conditions right now, and that's for this particular case. And then maybe you have another case where you have a different set of conditions, maybe different temperatures and pressures and flow rates, right? So you have other process conditions that you have defined within the simulation. It's good to have different snapshots for those different cases. And that allows me to come back to any one of the snapshots at any time and get back those states that I was in. So right now I can take a snapshot here with these conditions in place. And I can come to this section here, which is the snapshot manager, and I can see here's my Pro 1 snapshot, right? And I can come back to this state at any time simply by reverting this snapshot. And so what if I make changes here? 5,000. Just changing values, random values here. Okay, so I can change another snapshot for this state, right? And I can revert back and forth. So if I click on Pro 1 and click revert, I go back to what the values were there. If I click Pro 2, click revert, and go back to where the values were there. On top of this, I can not only revert the values, but I can also revert the solution, or it's not solution, the specification status. So maybe in this snapshot, I swapped around. So I swapped around these specs, and maybe I also swapped around these specs, right? And so let me overwrite the snapshot again. I can always overwrite what's in a snapshot by taking another after selecting it. And so now when I revert, I'm also reverting the spec box. It goes back as well. Okay, so there's a bunch of different options that are available to me here within the snapshot manager to be able to save and restore different information within my file. Now, why is this good for recovering from mistakes? Let's say in that example that we talked about where I added another valve and it wasn't solving, maybe it's because I made a change to one of my process conditions somewhere and I forgot about it, right? And so, I can come back to one of my snapshots and revert the snapshot to get back to a state where I was previously in that had a solution that may be more robust for whatever, I'm doing, right? So again, example, if I added this valve, right, and it says it failed because the pressure drop's too large, right? Maybe I have a snapshot here where the pressure drop isn't so large, right? Maybe I have a snapshot like this. It's still failing. It's failing because of a different reason now. All right, let's 1 second. Let's just do this. All right, so this snapshot fails because the inlet pressure was too small, right? But this one solved because it had a higher inlet pressure, right? And so that's one of the ways that I can use these snapshots to my advantage, right, to help me with making sure my file remains square and solved, right? So I can come back to the prior state, right? So this is just one of the uses of snapshots. We're going to talk about more in the sessions to come, but you're going to want to take snapshots frequently, and you're going to also want to export to a SimX file frequently so that you have backups that you can always come back to just in case you run into problems. General rule of thumb, when to take a snapshot versus when to export. If you're going to make configuration changes, meaning I'm going to add or delete models on the canvas, right? Typically, you want to export to a SimX file before you make those configuration changes. If I have a network such as this one here that's already built out, everything's already done, and all I'm doing is changing process conditions, meaning I'm doing spec swaps, I'm changing values, that's when you want to take a snapshot, right? And then there are a couple of other recommendations for taking a snapshot we'll talk about more tomorrow, okay? Okay. All right, I have two more things I want to cover, and then we'll open up the floor for questions. This might run just a smidge long today. When we were doing data entry, we were using this window here called the Mini Property Inspector. What's nice about this window is that everything is categorized. You can see these different groups here that break down the information into a very easy to find sort of navigation, right? There is another way of accessing your property information, which is called the Full Properties Inspector. If I right-click on the model and I go to Full Properties, this is going to show me the Full Property Inspector. And what's nice about the Full Property Inspector is that it breaks it down by all of my parameters and all of my variables. And then when you go into these different sections, you're going to find it breaks it down in here by what's in the main model, and if you have submodels, what's in the submodels. Now, because of my role that I'm in, simulation building role, I only see the main level information, and I only see what's called a favorite variable right now. While I'm in simulation building role, if I check this little star up top here, it turns it on to show me all the things that are marked as favorites, as well as all the other properties that are available to me. So now I can see the submodel information. I can also see these other properties here. And these are properties that would normally be shown when I switch my role, right? So you can see it's the same information here now, right? Normally when I'm in the mini PI, I would see that information when I'm in the model writing room, right? But if I'm in simulation building role, the mini PI doesn't show me that information. And this full properties doesn't show me it unless I turn this on. When I turn it on, I see it here, but I still don't see it here because the mini PI in simulation building role only shows me what's designated as a favorite, what has this yellow star. And because of that, you can turn things on and off from here to make it a favorite and change what's in the mini PI. So let's say I wanted to add the volumetric flow rate. I can click this, and now I can see volumetric flow rate. Do I need mass flow rate? Maybe not. So I uncheck this, and now I no longer see mass flow rate. Right? So I can turn these things on and off through this star. You'll notice sometimes if you make changes like this and it doesn't update, sometimes you just have to reload the window. Right, so now it's back to being there. Right, so while I'm in this window, there's a lot of other information that I can see here. And so we want to talk about some of the things that are here. The first thing is I talked about there are different sections. There's a main section and a submodels. Every single model will frequently have submodels for different types of calculations. And so almost every model has a state submodel for the equilibrium calculations. The state submodel is where the thermo is applied, right? So this is what's going to be doing your vapor liquid equilibrium calculations. And one of the things about this is that this is going to be the only area to find certain properties for certain models, right? In this case, if I wanted to find the density in this source, I'm not going to find it in the mini PI, and I'm not going to find it here in the main section. The submodel is where that property is calculated. You can see it here, rho. Okay? Greek letters are always spelled out, right? RHO, right? There's my density. So it's only available to me in the submodel. So one of the things you might ask yourself as you're using the software, I'm trying to find a property that I can't find, but I would normally expect to see that property in that model. You may need to come into the full property inspector and look at the submodels. All right, look at the submodels, and you might find the property in the submodels. Now, one of the things about that is once you find the property, you can use it just like any other property. If I wanted to, I could specify the density. I can free up, in this case, the vapor fraction. I was going to go with temperature, but vapor fraction was already specified here. And I can theoretically change this value and have it back calculate a new temperature and vapor fraction. Right? So I can utilize this just like any other property. Just because it's in a submodel doesn't mean I don't have access to it. Right? I can also create variable references on the canvas to make it easier for me to come back and find this later. All right, so I don't have to always come into the full property inspector if I pick the properties that I need and put them on the canvas as a variable reference. I want to talk for a second about naming conventions that we didn't talk about yet. Anytime you're referencing a specific property, it's almost always going to be the model name dot the property name. In this case, it's the submodel, then the property name. So model name dot submodel dot property name. If you have multiple submodels, because you can have submodels that reference submodels and so forth, it's just going to keep appending those within the submodel itself. All right, so if I come to the valve, for example, I have this curve window here that has properties, but that curve submodel is a submodel in the character submodel. And so it's XB1, the name of the valve, dot the submodel name, dot the submodel name, dot the property. Right. This is important because when we start to talk about how to reference different properties and other features, such as some of these tools output options, right? You need to understand how it's pointing to the specific property. It uses this naming convention here, right? Model, submodel, property. Also, you'll find naming conventions when it comes to referring to a specific model in a model library. This source comes from the process model library, process.source, right? So it's this source model in the process model library. This is how you know what it is that you're looking at, right? What is that model? Right. Right. So back here real quick. There are also other icons that are used for designating different things inside of models. In fact, I'm going to go into the valve because you should see a couple of these highlighted here. So there's this for user-defined properties, this for properties that are at their defaults, that are of key interest typically. This is for invariant properties. Invariant properties don't actually get reverted with snapshots normally. When you go back and forth between snapshots, an invariant property does not get reverted automatically. You would have to click this button here to restore an invariant property back to its value that's saved in the snapshot. Typically, invariant properties are physical sort of aspects. So in this case, the CV of the valve is typically associated with the size of the valve. And so when you're looking at different snapshots, you're looking at different cases. Usually you want to do case studies that go against the same physical constraints within the network, right? You think about it like a large piping system. The piping itself doesn't change just because the process conditions change. It's just, the same pipe length, pipe size, valve size, like all this information stays the same in these different cases. And so when you're reverting snapshots, you want the case information to change, but you don't want the physical information of the network to change. And that's why a lot of these properties get designated with this, so they don't update with changing snapshots. All right. I have a slide I'm going to skip to down here to show the others because it shows them in color so you can see them. So there's a required badge, which we talked about before. That's the main badge up on the toolbar. There's a global indicator. If it's a global parameter or a global variable, it'll have this symbol next to it, which means if you change it in that one model, every other model that also shares that variable or parameter, it's also going to change in those. Right. So that's what that means. If a value is out of range, it'll have this symbol. And if it fails to solve, it'll have this symbol. All right. And then I know we're 2 minutes over. I'm trying to speed this up. We've covered quite a bit of information in this first session. I knew it was going to be tight. So I do want to take a quick second to finish up. In the full property inspector, there are sorting and filtering capabilities. So this turns on filtering options here. And if you click at the top, including these icons, if you click on the top of any column, you can sort the list by whatever it is that you clicked on. Right, so that's another option. You will find that the sorting and filtering are not as useful in the full property inspector for a single model. Right, so we're looking at this for just this valve. But if you notice, I have 6 valves on this canvas. Let's say, for example, I want to change the pressure drop in every valve. I would have to go one valve at a time and change the values of the pressure drop. That's a lot of clicking. That's a lot of navigating just to change these different properties. One of the things that I can do instead is there is an equivalent full properties window for the entire simulation. If I come up here, I right click and I go to full properties. This is going to show me a full properties list for every single model in the simulation. Not only that, but instead of breaking this down by, quote, main model and then submodel, it's just one big list. And what this allows me to do is easily sort and filter the list for specific property information. So maybe I want to sort this list by process valves. Right? So now I'm looking at only the property information that's associated with that type of model. Right? So I see this. And now maybe I want to sort this so that I can see the pressure drops. Right? And even from here, without filtering this further, I could easily go through and change all of these pressure drops to my desired values without having to navigate from one model to the next, right? So this is an easy way to make mass changes across your entire simulation. You use the sorting and filtering capabilities with this full properties window to be able to do that. And I could also swap specs from here. Swap this for this. I could swap this for this, and this for this, right? And then I could hard code the CV values directly from here, as opposed to having it being calculated by the pressure drops. So there's a lot of flexibility in the way that you do your data entry here. Okay, we're gonna call it here. I'm gonna take some time to answer any questions for anyone who wants to remain on the line. There is one aspect of the session today that I did not get to cover that I wanted to cover. We'll start with that tomorrow, which is going to be some basic outputting capabilities. And so there's a couple of really basic output options that I didn't get to talk about. I'll start with those, and then we'll continue with the rest of session 2 tomorrow, which won't be quite as packed as session 1. Session 1 had a lot of information that we needed to cover. So I apologize for going a little bit over here. But with that, let's open the floor for questions. Berna, do you want to read them off, or do you want me to read them? Or
Yeah, we have 2 questions on the chat.
So I see one. Instead of building everything in one program, is there a possibility to integrate other models through model exchanger or co-simulation standards like FMI? We have scripting integration through Python that you can do. That would allow you to essentially build your simulation in APS by using coding through our Python interfacing capabilities. Outside of that, there's not really any good ways to build the APS model through a third party program. There are some integration sort of capabilities. One of the things you can do is if you do have an APS file that's already built, and let's say you have a plant historian with all this plant data, you can extract that plant historian data and use tags within your simulation file to populate information into the file. That's one example of an integration outside of the software to populate data in the software, but you will have already had to create the APS file already. And we have similar things with our Excel add-in, which is what we'll talk about on Thursday. The Excel add-in is an integration with Excel, and that allows you to extract data from your APS file into Excel and or write information from Excel back into the APS file. But again, you have to have your APS file already built. There's not really any other ways of building an APS file through another program other than the scripting capabilities. Hopefully that answers the question. Next software, so good. Awesome. What happens when you manipulate the sim files in the repository? For example, you cut and paste in another folder. So if you move the files, whether it's through a cut and paste or just move it, moving, anything you do like that, once the file is no longer in that folder, you're essentially not going to see it in the repository list, right? So here's an easy way to see this, because I don't need these files anymore. So let me close this. In my repository right now, I have Sim1 and Sim2. If I go to the repository folder, here's Sim1 and Sim2, I'm just going to delete them, but it could be the same as me moving them to another folder, cutting them and pasting them into another folder. It's all the same. Once they're gone and not in this directory, they are no longer eating my words here. They are not supposed to be in this list, because if I try to open it, see, it gives me an error. Now I suspect that once I click OK, it should hopefully disappear. No, it did not. All right, so in this case, it still showed them. That might be because I have the program already opened. I would have expected them to not even be seen there. But you can see what just happened there. It basically told me it can't find that file. Right. So there's a couple different ways that it could end up playing out there, but essentially once you remove it from that directory, you don't have it anymore. You basically lost the file. You would have to go and browse to wherever you moved it and do a file import. Right? So file import, go to wherever you moved it, such as the desktop, find the file, re-import it, and that would add it back to your repository. Right.
Perfect. Thank you, Richard. I think that was the questions. If someone else have another question, that's your time to make the question. And no, so thank you so much for joining this training session. Thank you, Richard, to share all those information with us. And tomorrow we will have the second session at the same time with the same link. So hope to see you tomorrow here. Okay. Thank you so much. Bye-bye.
Thank you, everyone. Bye-bye.